I know it sounds so crazy.
All right, so I need everybody quiet so we can get over this. So here is, we're going to start with this problem. And I apologize if it's one you've seen before, but we're starting with this one. Now, actually, on the bottom, it used to say 2x squared minus 2, but as I copied it down, I just couldn't help myself. I factored out the GCF. Ultimately, we are going to be finding all kinds of things, but let's start with the, what? Yes. Let's start, we're going to find a whole, we're going to find x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes, and then we have a whole bunch of limits we're going to find. That's the part I think she said you needed help with, but let's get these basic things down first. So, what do you think I ought to do? Factor everything, that's right. So how is this going to factor? Let's see. How's the top factor? So minus 5 plus 1, good. The bottom, once I take that 2 out, the bottom is the difference of
x plus 1, x minus 1.
Squares, x plus 1, x minus 1, very good. And then we notice we have a cancellation. And because we have a cancellation, we know that we will have a hole in our picture. All right, the only way to get a hole, and a hole is formally known as a removable discontinuity. The only way we can have a removable discontinuity, a hole in the graph, is if we can cancel. So we did. Where is that hole going to be? Where x is -1, exactly, because that's the factor that you canceled out, right?
Yeah.
Okay, Jackson, did you bring a pass?
No, I was trying to go see the nurse, but she wasn't here.
So we factored out a -1. Or I mean, we canceled out a -1, so our hole is going to be where x is -1. I got to plot that. I'd like to draw a picture of this. How will I know where to put it?
Plug it in.
I need to know its y coordinate, and I will find its y coordinate by plugging -1 in here. So -1 minus 5, 2 times -1 minus 1. That's -6 over -4, which reduces to 3 over 2. So I will plot that point, open circle, at -1, 3/2. Okay, that's not bad. All right, now, I need all the rest of that stuff though. So who can tell me anything? And remember, your B to lies are focused right here. We're not looking at any of that anymore. We've reduced the problem. This is where we're looking. So look at this and tell me what you can fill in. It's all right here. X-intercept is 5. The x-intercept is 5. And remember, kids, and this may sound a little babyish, but remember the intercepts are points, and intercepts always have one coordinate that's 0, and it's not the intercept you're finding. So if you're finding an x-intercept, y is 0. If you're finding a y-intercept, x is 0. So you know how we found this? Because we knew that was -1, so we plugged it in. Well, if you know this is 0, plug it in and you can get 5. Now we know x is 0, so if we plug it in, we plug in 0, what are we going to get? -5 over -2, 5/2.
Over what?
Over 2.
Okay, I'm just plugging in 0 for the x's. That's not, shouldn't be a challenge for you. Plug it in. Now what about my asymptotes? Where are they going to be?
Horizontal, 1/2.
Horizontal is y equals 1/2. And remember, when you do your horizontal horizontal asymptote, well, any of your asymptotes, they're equations. So it's y equals, or x equals,
Vertical is x equals 1.
Vertical asymptotes happen where your denominator is 0. It's called a non-removable discontinuity. X equals 1 is your vertical asymptote. So in terms of, let's see, have I plotted everything? I didn't plot my x-intercept yet. All right, now, have I plotted everything? Yeah. So now I should be able to graph it. Can you visualize a shape in there, given the points and the asymptotes that you have? Okay. So I think it's going to look like this. And like this. It has to contain the points that you plotted. And remember, as you draw your curve and you put these little arrows on the ends, those arrows are going to snuggle right up next to the asymptotes. So as you draw those arrows, you're coming in right next. You're hugging those asymptotes. All right, beautiful picture. So now I have a whole bunch of other stuff we need to figure out. So these are samples of questions like she's going to ask you on your quiz. So all this is on your quiz that you're taking tomorrow?
Yeah.
I don't know about, let me see if she's going to have you graph it. Yep, you're graphing it. So you're doing all this stuff. Okay, then you're also answering questions like this. Now these, the questions you ask tomorrow won't be exactly these. These are questions that pertain to the picture that we have just drawn. Tomorrow you'll be drawing a different picture, but you will be answering very similar questions.
Did you make any on there too? They're just positive.
I don't have them all written down yet. Okay, so we got these questions to answer.
We have to know how to do the limits on the quiz.
Yes, this is the quiz. That's why I'm going through it with you. Okay, but it's easy. It's easy. So you're already going to have drawn the picture, and now we're going to start answering these questions. Now, this says, tell me what happens to y. Remember, f of x is y. Tell me what happens to y as x gets closer to 0 from the positive side. So from the right. The positive side is right. So let's see. As x gets closer, here's 0. Folks, here's 0. As x gets closer to 0, what is my y getting closer to? 5/2. 5/2. There is a point there, kids. And as x gets closer to 0, actually from either side, it doesn't make any difference. As x gets closer to 0, y gets closer to 5/2. That's easy. What happens as I approach 1? Now this is a little bit different, because here's 1. What happens as I approach 1 from the left? So follow my curve in. What is happening to the y value as I get closer to where x is 1? Positive infinity. There's an asymptote there, so we're heading to positive infinity. Now what happens as I approach 1 from the other side? This is still approaching 1, but it's approaching from the positive side or the right. So what's happening as I get closer, follow your curve, negative infinity, it's going down. Now, this one says, what happens as x approaches negative infinity? So x is approaching negative infinity. So what happens as the curve heads to the left side of your paper?
It goes
What
one
is the y doing?
Goes to 1/2.
Getting closer to 1/2. And I don't know if she has you do this or not, but you could put a little plus up here, and what that would mean is we're approaching 1/2 from the top. Because there's two ways to approach 1/2, right? I could approach it from the top, or I could approach it from the bottom. So your calculus people are going to do that. I don't know if she has or not, but that's what that means. That means as we come out, we get closer and closer to 1/2 on the top of it. Let's go ahead and do this one. As we approach infinity, positive infinity, what's happening to the curve? As you approach positive infinity, off the right side of the page, what is the y value doing?
1/2.
1/2. But this time it's approaching from the bottom. All right. Now, what happens as we approach -1 from the left? -1 from the left. This is an x value. So it goes left and right, not up and down. So we're approaching -1 from the left. Well, here's -1. Follow your curve.
3/2.
The y gets closer to 3/2.
Even if it's a whole.
Doesn't matter. It doesn't say what does it equal. It says what does it approach. And the closer you get to -1, the closer your y value gets to 3/2, right? What if we come from the other direction? What if we come from the right? It's still 3/2, isn't it? As you approach -1, here is -1. As you approach -1, from either side, aren't they coming together? So as you approach from either side, it's going to be 3/2. Okay? All right, so let me, we have a bunch of stuff we gotta do today, but let me do one more, but we're gonna skip all the drawing the picture part and all that and just find the limits from the picture. So let's say I've got some weird random picture drawing. I'm making this up. This is some weird thing. So this is just some made up picture, and we're now going to answer some questions about it. So what's the limit? Oops. As x approaches infinity, as x approaches -infinity, as x approaches 0 from the right, as x approaches 1 from the left, as x approaches 2, okay. That's all I can think of. Let's see how we do here. All right, what's that first one say?
What is f of x and x goes to?
What happens to y? We're finding the limit of y. So what happens to y as x goes that way? So follow your curve X is approaching infinity, that means it's going clear out here. What is happening to that Y value?
Getting closer to -1.
Getting closer to -1
From the bottom.
from the from the bottom. Yep, you said from the bottom, and I wrote from the top.
Why
From the
isn't
bottom.
it 2?
This asymptote
So
is at
Y.
Y equals -1.
No, I know, but the whole is at 2 negative.
Okay, but X is 2 is the X value.
Or
This says
negative.
X is approaching infinity. Where does that happen? This is where X is 2. 3, 4, 5, 100, 2,000. X approaching infinity is that way.
Okay.
If I were interested in what was happening here, it would be X approaching 2. But I want to know off the page that way. That's where infinity is. This one is off the page that way. So what's happening off the page as you go out, what is happening to your Y values? Approaching -1
From the bottom.
from the bottom again,
Okay.
right? Both of these are approaching from the bottom. Now, this one says, now we're approaching 0. So X is 0 is right here, right? Well, it says from the right, but I really don't care. When there's a point there, it doesn't matter if I'm coming from the right or the left. What is the Y value? As X gets closer to 0, the Y values are getting closer to 1.
You don't have to put a plus or minus.
No, because there's a point there. Now, here's 1. I'm going to approach 1 from the negative side. There's an asymptote at 1. So I'm going to have to approach it from the negative side. So follow the curve. What is the curve doing as it gets closer to that asymptote on the left? Positive infinity. It's going off the page, positive infinity. All right, 2. Here's 2. This is where X is 2. What's happening as X gets closer to 2? Now again, I know it says from the right, but it really doesn't matter because there's a point there. So it doesn't matter which side I'm coming at it from. What are my Y's getting closer to?
-3/2.
-3/2. It doesn't matter. Oh, that's a -2, so that's over here. -2. Now I'm approaching -2. And I'm coming in from the left side. So as I come in from the left side, negative infinity. As I come in from the positive side, the right side, it is positive infinity. And 2 from the negative side, well again, if you have a point, you don't really have to worry about left side and right side, because if you have a point, they're coming together. So what's the value of that limit? -3/2, yeah. Okay, so that's what's on your quiz tomorrow, only you will have to draw the picture to start with. Okay? All right. All right, so now we got 2 other things to do. The first one, you have a packet of stuff she gave you already, graphs to do, and she said we are to focus on the problems that have slant asymptotes. So I'm talking about this packet right here. It's called 2.6 Graphs of Rational Expressions. And I am going to skip, I don't know how much of this you've done. If you've done it all, then you'll have to be bored, because we're going to do, starting with, it's not numbered, but it's the last page. So starting with the last page, we're going to do this. Now, the reason that I skipped all the rest of it is she told me to focus on slant asymptotes, okay? And when I look at all the other problems, for example, the first one at the top of the first page, on the back side, if you look at the back side of the first page, That one doesn't have a slant asymptote. It has a horizontal asymptote at y equals 1/2. And the one under it has a horizontal asymptote at y equals 3. And the one under that has a horizontal asymptote at y equals 3/2. But look at the first one on the last page. It does not have a horizontal asymptote. Why not?
That's the slant one.
Because the power on the top is bigger than the power on the bottom. Remember, when you have x squared over x squared, your horizontal asymptote's at 1. If you have x over x, x cubed over x cubed. But when you have your biggest power on the top, you no longer have a horizontal asymptote, you have a slant asymptote. You guys already talked about this? Okay, well then this will be easy. Okay, so we'll fly through this. So everything we're gonna handle the same otherwise. So I'm gonna factor. I'm gonna see if anything cancels. Nothing does. What does that mean, since nothing cancels?
No holes.
No holes. We simply don't have any, that's okay. I do have something in the denominator though, so I'm gonna have a vertical asymptote at -2, x equals -2. I know I'm going to have x-intercepts at -3 and 1. So I have 2 x-intercepts, one's at -3 and one's at 1. I know I'm gonna have a y-intercept, I'm gonna put in zeros here. So 3 times -1 over 2, -3/2. So I have my vertical asymptote, I have my x-intercepts, or my zeros, I have my y-intercept. I've already determined there's no horizontal asymptote and there are no holes. So I'm going to be ready to sketch this when I find my slant asymptote. They're also called end behavior asymptotes. She may be calling them end behavior asymptotes. So, how do I find my end behavior asymptote? We divide. So we literally do the division. Now I like to do it synthetically. You can do long division if you like, but I don't know why anyone would ever do that. Synthetic division is so easy. We're dividing the top, 1, 2, -3, by the bottom, -2. So this comes straight down. And when I write my answer, when I look at this list of numbers right here, remember the original was x squared? So this one's going to be x, right, plus 0, and then that's a remainder. Now the good news is when I'm doing slant asymptotes, I don't worry about the remainder. It's like it's not even there. Don't even worry about it. Y equals x is my slant asymptote. What does y equals x look like? It's a line, goes through the origin with a slope of 1. So it pretty much looks like this, would you agree?
Yes.
Your vertical asymptote, remember gang, acts like the great divider. This splits everything into 2 pieces, so you're gonna have something drawn on the right side of my arm and something drawn on the left side. You'll never have 2 things on the right or 2 things on the left. There's 1 piece over there and 1 piece over here. It's pretty obvious to me that the part on the right is going to look like this. You see that? And now I got to draw something on the left side of my arm. On the left side of my arm, I got a point sitting right here, so I guess it looks like this. And just like before, when you put those arrows on the end of your curve, make sure they're snuggling right up to those asymptotes. That's how we draw it. And that's it. That was easy. That was easy. We got 1 more of those, it looks like. So let's try this one. let's see, top factors, how does the top factor?
X minus 2x plus 1.
Minus 2 plus 1, perfect. Alright, so let's put in here what we know. Again, there's nothing that cancels, so that means I just don't have any holes, that's fine. I don't have a horizontal asymptote because my power on top's too big. But I do have a vertical asymptote. Where's it? X equals 3. I do have intercepts. I have 2 x-intercepts, or zeros. Those are at 2 and negative 1. I do have a y-intercept. If I put in a y-intercept, I put in zeros, I get negative 2 times 1 over negative 3. Did you get 2/3? Is that right? And now I'm all set except for my slant asymptote. So how do I find that again? Real easy. Sympathetic division. So out here I'm going to put a 3. Don't worry about the remainder. Did I divide right? So that represents the equation y equals x plus 2. Remember, this was an x squared in the original, and whenever we do division, that goes down by 1. So what's that? That's a line. Y-intercept is 2 with a slope of 1. Remember what Ms. Ford told you. This is the great divider. So there's going to be something drawn on the right side of my arm, and there's going to be one thing drawn on the left side of my arm. No overlap. So I think on the left side, it's pretty easy. Can you see something that looks like this over here?
Yes.
Don't be confused. My body is the divider. You've already drawn something behind me, so now everything you draw has to be in front of me. What are you going to draw over here? You got to draw something. What are you going to put? Exactly. Well, not really a problem. It's kind of like this.
Yeah.
That's exactly what you're going to draw. Now, somebody might say, oh, Mrs. Ford, how do you know that you're not drawing something like this? Because that's a possibility. And it absolutely is a possibility, except for what?
There's no 2 x-intercepts.
There's not an x-intercept. Can't be that. Can't be that. Because you already plotted the intercepts. So the only choice you have is to draw it in that little spot up there. Got it? Task 2 complete. Okay. Last job of the day. We are to solve, and she ran out of copies or something, so she doesn't have copies of this for you, but I'll write the problems down, and so you'll just put them in your notebook, on notebook paper. Alright, if we get through this, I might give you a little practice quiz, but we gotta get through this material. All right, so this is different. We are completely shifting gears. We're going to solve these equations. They are not hard, especially these first few. They're very easy. We're going to solve these equations. They are called rational equations.
What lesson?
2.7.
Thank you.
These are rational equations. We're not graphing them. We're going to come up with x equals 10 as an answer. That's what we're going to do. X equals 1. So you look at that equation, I bet you already have a thought because you've done these before. What do you think about this? How would you go about solving this? Multiply everything by x. Because that doesn't write very well. If you multiply everything by x, won't these cancel? And now you have x squared plus 3 equals 4x. Now what do you do with that? I don't factor it yet. Before I do anything, I need to get it set equal to 0, and let's go ahead and put it in the right order. You know what I mean, descending order. Now I can factor it, or it is absolutely possible it won't be factorable. If it isn't factorable, or if you just don't want to factor it, you can always use the quadratic formula, right? I think it factors.
It does.
Sometimes they don't, but this one does. So x equals 3 or x equals 1. I would say that's pretty easy. Right? Alright, what are you going to do with this guy?
Multiply by
Exactly the same thing. And exactly the same thing's going to happen right here, right? That's why you did it. I know some elementary teacher at one point told you fractions were your friends. It's a lie. Get rid of them.
Yeah.
So we're going to multiply everything by x, no fractions. Now we have x squared plus 2x equals 15. So x squared plus 2x minus 15 equals 0. All right, back to where we were. We're going to factor. How does this one factor?
X minus 3x plus 5.
Plus 5 minus 3. Either order. Obviously, it doesn't matter what order you write those. So x equals negative 5 or x equals 3. Okay, we could do these with our eyes shut. What about that one? Multiply by x minus 4. X minus 4. And I know it's a 0, kids, but you are supposed to multiply both sides. So the good news is anything times 0 is just 0. That's going to cancel. I'm left with x squared minus 4x plus 1. Is that right? Uh-oh.
Yes.
It doesn't factor. So we're going to have to use the quadratic formula. X equals
-4
negative b plus or minus the square root b squared minus 4ac over 2a. Right? So what do we got under there? 4 plus or minus the square root of 12. Uh-oh, the square root of 12 is, what's the square root of 12? 2 root 3. Uh-oh, see how we got 2's all over? So our final answer is going to be x equals 2 plus or minus root 3?
I know. Somehow I've turned into a petition over the last 35 minutes. I haven't done so much in one class.
All right, now, this one's a little bit harder.
Is it just 2 plus or minus root?
Yeah, I don't know what that is.
All right, now this one's a little bit harder because it has 2 denominators, but the procedure is exactly the same. In order to get rid of both denominators, we are going to have to multiply by x and x minus 1. So we're multiplying by both denominators, x and x minus 1. And we're doing it to every term of the problem, including the 8. So one denominator was x minus 1, one denominator was x. My goal is to cancel them both out, so I got to multiply by both of them. Now the x minus 1's will cancel, leaving me with 3x plus. Now the x's are going to cancel. 2x minus 2 equal to, nothing cancels, so I have to keep it all, 8x squared minus 8x. So I have 5x minus 2 equals 8x squared minus 8x. What do you want to do with that? Put it all on one side. I love that. Kids, a quadratic equation, if you got a squared in your equation, you got to have it set equal to 0. Get it set equal to 0. I have this thing about negatives here, so I'm not going to move this way. I'm going to go that way. So 0 equals 8x squared minus 13x plus 2.
Quadratic.
Yeah, I think I need the quadratic formula. I'm not seeing any factoring, and I just don't have time to mess with it, so I'm just going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what's going to be under there? 13 plus or minus the square root of what? 32, 64, 105? Is that right? 105? I don't think that breaks down. So there's my answer right there. That's it. Too much talking over there. Okay? Oh Lord, now this one is a little bit harder yet. I want you to look at that for a second, and I want you to tell me what seems logical to you to start. Factor that denominator. Please don't ever work these problems without factoring all of your denominators. Now these don't factor, so I have to leave them alone, but this one does factor, and magically, how does it factor? X minus 3x minus 1?
Oh, that's good.
Isn't that nice?
That's what you like to see.
This is what math teachers do on Saturday nights. We sit around and rig these problems, so it works out beautiful for you people. Multiply everything by x minus 1, x minus 3. Please do not be lazy. Write x minus 1, x minus 3 next to every single term. And then all of your denominators should cancel out. So this cancels, and I am left with 2x times x minus 3 plus this cancels, x minus 1 equals, the whole shebang cancels and leaves me with just 2. Right? See how wonderful that is? Kids, this is what you want to have happen. So now we have 2x squared minus 6x plus x minus 3, if I bring that guy over, equals 0. So I got 2x squared minus 5x minus 3. That one does factor if you want to factor it, but we're kind of on a roll with our quadratic formula, so feel free to do that too. Anybody see how this one factors?
2x plus 1, x minus 3.
Perfect. Beautiful. I'm almost 60, but I never, ever factor without doing a quick check in my head. Negative 6, positive 1, that's how I get that negative 5 right there, so I know that's factored correctly. And my solutions are negative 1/2 or 3. These are called my extraneous root radar. This is an extraneous root. I didn't make any mistakes, we did everything perfectly, but that will not work. Why won't it work?
Because it's in the denominator.
When you put it right back into the original, it makes the denominator 0.
Can't divide by 0.
Can't divide by 0. So this is always in the back of my mind. The problem that we did over here, what would have been the extraneous root numbers over here? 1 or 0. Since we didn't get 1 or 0, it wasn't a concern of mine. If you look back at all the other problems we've done, it hasn't been an issue. This is the first time. You always have to pay attention to that. So when I write my problem down, I just kind of make a mental note. Okay, 1 and 0 are going to be problematic. 1 and 3 are going to be problematic. So as soon as I got 3, I said, whoops, got a problem. Throw it out. So the only answer to the problem is -1/2. Got it? Okay, there's only one more on this side of the sheet, so I'm going to have you do this one on your own. Oh. I'm not going to have you do that one. I'm going to have you do this one. If she wants to struggle through this great big ugly problem, she can, but we're going to do this one. Alright, would you do this right now on your own, please? This is the problem. See how far you can get with it. Once you get it copied down and get started, I'm going to go ahead and work on it up here. And then we'll see where you get stuck, or if we get the same answers, or how it all works out. So get that copied down, please, and start work on it. What are you doing on your iPad?
Seeing if we had anything in school you could.
Okay, you know what? This is not the time to do that. That's outrageous. Come on, get busy. That's offensive. I find that insulting. All right, everybody's got it written down. Don't look up here. Try not to look up here. See how far you can get on your own. Remember that the first thing Mrs. Ford told you to always do is factor your denominators. So if you forgot to do that, please go back and factor your denominators. What you got?
We got x times x plus 2 is equal to 0.
So then you set these equal to 0. So x either equals 0 or x equals -2. Beep, 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 beep. Those are what make my denominator 0. Right? So I forgot to throw them both out, and there's no solution to this problem. So you did all that for nothing. Okay? All right. Let's see quickly. I think we can do a quick quiz question. for practice, just to get ready for tomorrow. So you have already found all of your asymptotes and your holes, and you sketched the picture. And you have gotten some kind of thing that looks like this. Okay. So then I just want you to fill these in. I want you to fill them in by yourself. Pretend it's a quiz.
Will lim fx and all that be written on the test result?
Yep, these are just going to be answer blanks you fill in here. Yep. So these, you're just putting either numbers or infinity symbols in there. About a few more seconds here to get all those filled in. Let's see who can get 7 out of 7. Don't forget Math League tomorrow. My friend Chuck Lofton on Channel 13 this morning said we may get a dusting of snow. Keep that in mind. Got to be in the room in your seat at 7:15. Not flying in the door at 7:15. In your room, in the seat, 7:15. Leave early. Most
Too
fun
bad
you'll ever
for
have.
people that get here at 7:16.
Too bad for them, right? Leave earlier. Alright, here we go. X approaches positive infinity. What'd you say? We're heading off the page that way. What'd you say?
2 from the
2 from the
bottom.
bottom. Very good. How about going the other way? What happened going the other way?
2 from the top.
2 from the top. Very good. How many got those right?
I just put 2.
You're wonderful. I don't know how she's going to do it. Okay, now 0. We're approaching 0. Here's 0 right here. X is 0 right here. There's a point there, right? I don't care which side you're coming at. If there's a point there, the answer is 1/2. Now we're approaching 1. Here's 1. There's a point there. 1. Approaching -3. No point. This is an asymptote. So as we're approaching -3, we're coming in from the left side.
Yep.
Down there, left side. So as we're approaching -3 from the left side, what is my pen doing? Positive infinity. Very good. What about -3 from the right side? -3 from the right side, my pen is going down. Remember, your limit is y value. Finally approaching 1, again, there's a point there. So the answer is 1. Who got it all right? Okay.
I got 6.5 out of 7.
Whatever. All right, let's stay quiet until we have the blessing. So tomorrow, I made a note of what I've done, so she'll be ready to pick up with you after your break.
Today, on the day that we want to recognize the veterans. Today I thought that we could remember all those who have served in our armed forces, and died for us. So